However, if we look at a different value of x, for example, x equals -2. At x equals -2, this function has a break in it. You see it? The left-hand piece is disconnected from the right-hand piece. Things are going to behave a little differently here for the left and the right-hand limits. If we do the limit of k of x as x approaches -2 from the left-hand side, what's this going to look like? Well, in this case, we're approaching -2 from the left-hand side. If we approach from the negative side, it looks like we're headed to that point right there. It looks like we're headed to a y value of +2. However, if we approach x at -2 from the way you indicate the right-hand side is with a plus for this function, what that's going to tell us to do is to approach -2 from, I'm going to draw a big arrow, from the right-hand side. Now, if we're approaching from the right-hand side, we're going to not be on the left-hand portion of the graph, but we're going to be on the center portion of the graph, and we're going to be coming this way. If we're coming from this direction, as we approach x equals a -2, it looks like we're headed to this point. At that point, the y value is 4. So what can happen is, if you approach from the left-hand side or the right-hand side, you're going to wind up at two different values for the limit. Let's take a look at another example. Let's do this limit of k of x, and this time we're going to allow x to approach 3, +3, from the left-hand side. Notice the notation here is slightly different. In the very first problem we did, x was approaching -3. Okay, x was approaching -3. Now x is approaching +3. However, in each case, it's approaching from the left-hand side. Okay, so let's take a look at what's going on. We're approaching +3 this time, but from the left-hand side. That means we're coming in this direction here. As we approach from the left-hand side, that means we're following this piece of graph here. And in following that piece of graph, it's leading us to this point right here, which has a y value of 1. If, however, we approach x equaling 3 from the right-hand side of this same function, okay, so what's going to happen is we're coming towards 3, but this time from the right-hand side. If we're approaching from the right-hand side, we're no longer on the center piece of the graph, but we're on the rightmost section of the graph, which means we're going to be coming down this slide here, and we're headed toward this point. Now, a lot of times folks will say, well, wait a minute, we can't get to that point. It's a open or hollow dot. And you're absolutely right. We can't get to that point. But remember what a graph is asking you. It doesn't ask you where are we going to end up. It just says, where does it look like we're going? Well, as we come down this slide on this right-hand portion, it looks like the y value we're headed to is -3. Okay. Let's try another one of these. I'll draw some function here. And let's say that the graph does something like this. And it's a solid dot there. Let's say this is a -2 and this is a height of 1. Then it starts here and it goes down to, let's say, 1. That's looking too close to vertical there. There, something like that. Then maybe I put a point right here. And this point is a -1. And this is at x equals, oh, I'm making something up. Let's say it's at x equals 3. And up here, let's say this value is 4. And now I'm going to do another open dot here and just go like this. And let's say at 6, we're crossing the x-axis. Okay, we can look at a variety of limits. For example, we can do, I guess I have to name this thing first. Let's call this function g of x. We can do this limit of g of x as x approaches, let's say, 3 from the negative side equals the limit as x approaches 3 from the positive side of g of x equals. Do those. Pause the video. See if you can figure these out. And then once you have answers for these, start it up and we'll work it out. Okay, so hopefully you actually paused the video and worked on each of these two limits. In the first of the two limits, notice the notation. We want to come toward the next value of 3, but it's from the negative side. So what that's telling us is on our graph, we want to come from the left-hand side to the right-hand side, moving toward 3, an x value of 3. If we're moving towards 3, that means we're going to be on this portion of the graph, following it. As we follow along on that portion of the graph, the closer we get to 3, the closer the y value gets to being a value of 1. Now, the limit is 1, and you may say, well, but you never get to a value of 1 because there's an open dot there. You don't get to 1. And that's true, but remember, the idea of a limit isn't where do you actually get to? The question is, where does it look like we're headed? Well, if you follow along there, it sure looks like we're headed to a y value of 1. The second of the two limits that you were asked to look at, still approaching an x value of 3, but this time from the right-hand side. So that means that on our graph, we're going to be wanting to come from right to left, which means we're going to be on a different segment of the graph. We're going to be on this rightmost segment, headed that way. Now, looking at this, I happen to realize, gee, you're missing some information here that might be handy, but you could take a guess at it on what you estimated the value to be. Once again, the question isn't where are we actually at when x is 3, but where does it look like we're headed as we're coming down this rightmost section. As we're coming down that rightmost section, I realize you had to kind of estimate it. Maybe you put -2, -3, -4. But now that there's actually a value defined, you can see that this is -3. If you were asked to evaluate, here comes a different question now. Pay attention to this. G of 3. Notice this is not a limit this time. This says look at the function. When x has a value of 3, what's the result? Well, x having a value of 3 is that point right there. The y value at that location is -1. So be very careful. There's a difference between a limit and evaluating the function at a point. I'm going to draw one more here for you, and we'll see what happens. Okay, so example 3. let's say that we have something, I'll tell you what, let's do something like this. Let's say we have g of x is equal to, and it's going to be a piecewise function. Let's say it's x minus 4 if x is less than or equal to 1, and 2x plus 5 if x is greater than 1. So this time we're not using a graph, but we're going to do this numerically. If you are asked to evaluate the limit of g of x as x approaches 1 from the negative side, the way this would be handled is, remember, we're coming at 1 from the negative side, which means to the left of 1, so values smaller than 1. Oh, that means we're going to use this first function. Using this first function, that means that we're going to plug the 1 into the first function. So we're going to have x minus 4, which is going to give us a negative 3. If we do this same limit of g of x, changing from a left-hand limit to a right-hand limit, notice we're coming in from the direction where x is bigger than 1. That means we're now going to be evaluating using this second function. In the case of the second function, just like the first one, it's defined at 1. Okay, but what we're going to wind up doing is we're going to take this function 2x plus 5, and we're going to substitute in the value 1, and that'll give us 7. Notice here, these two are not equal. That's fine. That just means that we have a break there. That is entirely possible. You don't always have to have a situation where the two are equal. Okay, we'll talk about that as we move into the next video on limits. But for right now, between the video part 1 and this video part 2, which addresses several examples with left and right hand limits, you should have everything that you need to do the homework that's assigned at this point.